All right, so we're going back just to kind of revisit our friends multiplication and addition here, and to make sure that we see the connection between them. Because again, as you saw from the previous lessons, now our variables, in other words, our letters, are starting to come out to play a lot more. So we want to kind of show you the relationship that's between them, so it doesn't feel like that it's something completely that's foreign. So the whole idea here is we want to write two different expressions, which means two different ways that we can show it. One, we want to include addition, and the other one, we want to include multiplication. So the whole idea here is I got 3. I'm going to add 3 more on, and oh, look, I'm even going to add 3 more on. All right, so the 3 plus the 3 plus the 3 is an expression. Now we don't need to solve it, but we can kind of just to kind of show the point there, which is 9. Or the main idea here is repeated addition is the same as multiplication. So if we take the number 3 and we repeat it 3 times, it's the same as multiplying, and we still get the answer 9. So there's my two expressions. A repeated addition is the same as a multiplication problem. So here I've got 1, 2, 3, 4, 5, 6, 7, 8. I got 8 of them, and I'm going to add on another 8. So 8 plus 8 is the same as taking a group of 8, and then since we wrote it out twice, we multiply it by 2. And for the last one that we've got there, we've got groups of 5, 1, a 2, a 3, a 4, and a 5. So I can do a 5 plus a 5 plus a 5. All of that is the same as taking a 5, and because I have 3 groups of them, and multiplying it times the 3. So again, repeated addition, and this is a good thing to write down here, repeated addition is a multiplication problem. Woo, that took a long time to write out there. Easier said there. But yeah, repeated addition is a multiplication problem that we're dealing with. So here they want us to write the addition sentence that describes the model, and the multiplication sentence describes the model. So again, we've got a group of 5, and oh my, another group of 5, and oh my, another group of 5. So we can add them all up, or just as we saw from the previous problem, we've taken a 5 and we're repeating it 3 times, so 5 times 3. All right. So again, not as much as we're interested in solving. The solving kind of helps us out a little bit with it, but it's not necessary, but it does confirm that we feel good about our answers. So what we want to do on the next section here is simply write an equivalent expression, which means something that's equal to it. So we're not solving, we're just writing something that's equal to it. So if they give you addition, write it as multiplication. So 6 plus 6 is the same as 6 times 2. I get the number 6, and it happened twice. I got the number 3 here, and it's a 1, a 2, a 3, a 4, a 5, a 6. It repeats 6 times, so that's the same as 3 times 6. I've got the 4, and how many times does it show up? A 1, a 2, a 3, a 4, a 5. So again, repeated addition is the same as multiplication. Now with part D, we're going the opposite direction. They're giving us a multiplication, which means it's a repeated addition problem. So we've got 2 ways we can write it out. We've got the fast way, which means always start with a larger number. We've got a 6, and we're going to add it together twice. Or you could use the 2, but then you got to add it together 6 times. 1, 2, 3, 4, 5, 6. So that's why it's always easier to end up grabbing the larger number, because you'll have to write it out less. So for the next one, I'm going to grab the 6, and I'm going to add it together how many times? Well, there's the 4 that's there, so 4 times. Or we could use the 4, but we'll have to add it together how many times? The 6. So 4 plus the 4. There's 3 of them, 4 of them, 5 of them. Oh my goodness, running off the page there. Let's sneak it below there. There you go. 1, 2, 3, 4, 5, 6. So that's the whole idea behind it. Next one here, I'm going to use my knowledge. I'm going to start with a larger number, and so because it's multiplication, it's repeated addition, so it's going to happen 3 times. So that's all nice. That's all wonderful, but this is what we're really after. Our variables are coming out to play now. So if we take the letter H, all right, and we add together 1, a 2, a 3, a 4, a 5 times, it is H. All right, and it would be times 5. Now, the only thing is what we got to watch for, all right, is that when we multiply a number and a letter together, the number must always come first. Also, the number must always be up against the letter. So those are 2 rules here. It's always number first, and 2, we I guess what's the best way of saying this? We place them up against each other. They have to touch each other. I guess we'll say that. Place against each other. I'm not overly happy with that. But you get the idea here. The main thing is bad would be something like this. Boo. Okay. Because now all of a sudden we've got our letters that are in there, so we can't have that. Something else that's bad as well is that. All right. It is the same thing. It's just it's poor math grammar. So that's the thing that we want to watch for here. So not only do we want to make sure we're getting correct answers down, but we also want to make sure we're using our good math grammar. So let's look at letter H here. It says 6y. So again, multiplication is the same as repeated addition. So you're going to take that y and it's going to appear 6 times. So y plus y plus y plus y plus y, 1, 2, 3, 4, 5, and then 6. Now you might be thinking, whoa, what about the other way? I mean, because the other ones you're able to do 2 different ways. But here's the thing. If we start with the 6, you're going to write it out y times. Well, how many times is that? Well, we don't know what y, so that's why we can't do that. So when we are dealing with our variables, we will always write out our variables to go along with it. Because we don't know what y is. And again, different situations, we do have different amounts that we're dealing with. We'll skip that question number 3. Let's go to question number, I keep bouncing around here. Let's go to question number 4. I know I kind of passed up on that a little bit. Here we go. All right, so tell whether the following number sentences are true or false, then explain. All right, so what we want to notice here is don't get all, oh my goodness, what are all the, look at this. We are adding 6g and then taking away 6g. So they undo each other, so it's simply, yeah, it's x. It is x, so it is true. All right, explain, and then you can say something like there, opposites don't change the starting amount or the beginning value. A lot of different phrases we can say here. The main thing is when we do opposites, they knock each other out. They undo each other. So keep that in mind. So hopefully we're starting to write, and oh, look at that. These are opposites, subtracting 4e and adding 4e. So yes, this is also true. And it is the same reason. It's almost as if I knew that was going to happen ahead of time. So yeah, so again, we do have our opposites that are going on here, so they do knock each other out. 5, write an equivalent expression to demonstrate the relationship between addition and Okay, so this is the same stuff, but now all of a sudden we've just got a little bit more that's playing with it. So for example, the number 6 appears, and it appears 4 times. So repeated addition is, yes, multiplication. So 6 times 4. Now, it's not going to be a multiplication problem here because I've got a new group I'm dealing with. So we're going to add on, but then I've got the 4 that's there and it appears 1, 2, 3 times. So 4 times 3. So yeah, I got a 6 times 4 and then a 4 times 3. Faster to do the multiplication than to do the addition. That's there. So let's look at the letters B and C here. So letters. Now remember, I got to start with the letter here and it appears 3 times, so it is 3D. And then I'm going to add on to it, and then the W, and how many times? 1, 2, 3, 4, 5, so it is 5W. Again, repeated addition is multiplication. And again, notice how I've got them written out. I do have the number first followed by the letter, and they are up against each other. All right. Take a moment and try C. All right, and let's see what you got here. Did you have a 2A? Did you add on to it a 3B? Did you add on to it a 4C? Again, the C happens 4 times, the B happens 3 times, and the A happens 2 times. So we are adding them on each time. But again, the grouping, okay, we can rewrite that as a multiplication. We can rewrite it as, it's like a bonus problem. I mean, it's like 3 problems within one. How exciting is that? I know. All right, so let's go to 5. 5 is our friend, the exponents that are here, which we've seen before. We're just formalizing them with our letters that we've got going on here. So repeated multiplication, all right, and so this is the difference there. Repeated multiplication uses exponents. All right. So when we had repeated addition, it used multiplication. When we have repeated multiplication, we use our exponents. So we have 5. It happens 1, 2, 3, 4, 5 times. Ooh, 1, 2, 3, 4, 5 times. So yeah, so it is 5, and it is to the 5th power. That's our exponents there. All right. We do have a 2, and we're multiplying it together 1, 2, 3, 4 times, so it is to the 4th power. Your exponents are smaller numbers and pushed up in the air. So if it's 8 to the 3rd power, that's really doing 8 times 8 times 8. I don't need you to evaluate right now. I know it says evaluate up there. I just want you to rewrite. So 10 to the 6th power, 10 times 10 times 10 times 10. There's 4 of them, times 10, and then times, 10. Again, this is why exponents kind of serve their purpose, is because having. Now, the real thing that we are after here, the variables. All right, I'm going to take the letter G, I'm going to multiply it 3 times because the exponent is a 3. So G, a times a G, a times a G. All right. Don't worry about going back and using the calculator. Don't worry about that. Oh my goodness, this one. This is what we want to watch for. Okay, this is the one that you want to pay attention to. What's the difference between 3g and g to the 3rd power? Okay, so the big thing here is 3g is the same as g plus g plus g. All right, and g to the 3rd power is the same as g times g times g. So the difference here is 3g is repeated addition, whereas g to the 3rd power is repeated multiplication. Oh, M-U-L-T. We'll abbreviate there. All right, repeated multiplication. So that is a huge deal. All right, put a star next to it, an asterisk next to it. Put little glasses to make you look. Get it? Yeah, see, look. All right. Whatever you did, but that is a huge concept there that we want to make sure we're taking care of. All right. 6 through 8, we're not going to have you multiply large decimals together and stuff like that. It's not really a good benefit of our time. We do want to realize what does it mean in 3 and 8 tenths. And this is why we use parentheses, because if I use the dot for multiplication, it can just look awkward with our decimal that we've got there. So we can do that 4 times. 2 and 1/10, 2 and 1/10. Now, when we have a decimal, you will see it wrapped in parentheses a lot of times, because otherwise it looks like the 2's just up against the 1. So those are just visual things that we do to help ourselves out. So that would mean to be 75/100ths. We'd wrap it in parentheses, and there's 3 of them, so it's to the 3rd power. So again, little things that we end up doing. These last 2 guys we're going to make sure we solve as well. All right. So if we do write it out as an exponent, it would be 1/2. And again, repeated multiplication, so it's an exponent to the 3rd power. When we do multiply it out, we can multiply 1 times 1 times 1. Yes, that's 1. 2 times 2, 4. 4 times 2 is 8. So it does give us an answer then of 1/8. So we do want to be aware of our fractions that are there. And then 2/3 to the 2nd power, which means 2/3 times 2/3. And again, the instructions here, we are letting you know we do want you to go ahead and fully solve for as well. So rewrite as a multiplication and then solve. So 2 times 2 is 4, 3 times 3 is 9. So we do want to be aware of that as our answer that we're looking at. So our fraction is certainly going to come out and play a little bit here. The very last thing that we've got is just filling in a table and then some words that we've got to go along with it. So fill in the missing chart. Standard form just means actually to solve for it. So if we see a 2 times a 2 times a 2 times 2 times 2 times 2, that is 2 to the 6th power. All right. And if we actually multiply it out, 2 times 2 is 4, times 2 is 8, 8 times 2 is 16, 32 is 64. So we place our 64 that's in there. It's a table, so I'm a little problem with it there. So here's what I want you to do is I want you to finish this. All right. So you do need to fill in the rest here. All right. And get that taken care of. So if you want to pause, go ahead and do that. We'll check answers in class tomorrow, but I do want to make sure we're familiar also with these words that are down here. Cubed. That means something to the 3rd power, so 5 to the 3rd power. So cube does mean to the 3rd power. So that's a phrase we want to remember. And then squared. Okay, squared does mean to the 2nd power. Something I have to be aware of as I look back up here is I got to do a better job with my 5s. All right, otherwise they look like S's. So 14 and 7/10 squared. So 14 and 7/10 squared. Again, I'm not going to have you put that, write all three of them all. I'm just going to have you write that out. I'm not worried about you multiplying that out. And again, for this one, I'm not worried about you. I just want them in exponential form. That's it. All right. Very last question. And again, this happens a lot. One student thought 2 to the third power was equal to 6. 2 to the third power, they said it's equal 6. What mistake do you think they made? And again, it's common. A lot of people are like, yay, 2 times 3. No. There's small little numbers. You got to treat them differently here. All right. It's like little babies there. You just can't simply give them a fork and a knife and say, hey, feed yourself. Knives are dangerous for little kids if you didn't. Okay, anyway. Even plastic ones probably aren't the best ones. But what mistake do you think they did? Well, they probably multiplied, all right, which is a no-no, all right. Now, we are going to have to multiply in here, but remember, it's repeated multiplication, a 2, a times a 2, a times a 2, which would give us 8. So, hopefully you got that. Again, the exponents there hopefully is a little bit of a repeated pattern. And we'll work on this more tomorrow in class.